Today we're going to look at 1998 free response question number 6. It's a calculator allowed problem. The first instructions are to show that the derivative of y with respect to x is given by that expression. This is clearly, and you need to be able to identify this is clearly an implicit derivative. Implicit derivative because I've got y's throughout here. Okay? We'll go ahead and apply that derivative operator to both sides. Derivative with respect to x of both sides. Derivative of 2y cubed, we're going to use power rule with chain rule. That will be 6y squared times dy dx. You can use y primes if you prefer, that's okay. Y prime is also notation for dy dx. Plus 6, now I've got a product rule. I've got x squared y, so I have to use the product. We'll go ahead, x squared is the first function, y is the second function, and the derivative of a product will be f g prime, and y prime in this case is dy dx, plus the derivative of the first derivative of x squared is 2x, and I leave the second function alone, so I put a y in there. Okay. Negative 12x squared should be the easy part. Give it to me. Negative 24x, and the derivative of 6y is 6 dy dx. Please be careful on the right-hand side. What is the derivative of 1? 0. Most common mistake is to leave that as a 1 over there. Anytime you've got a constant on the other side, it becomes 0 when I apply the derivative. Okay? Good so far. Now, we've done all the calculus, guys. We've done all the calculus required in this portion. The rest of it is algebra, which is consistent with calculus is the easy part, algebra is hard. Question? After the 6y squared. Good question. Isn't it supposed to be a plus here after the 6y squared? That is a multiplication because of the chain rule. It's a function. It's a composite function. 2y cubed is my composite. So the exponent comes down, the exponent gets reduced by 1, but then I've got an inside function I'm going to multiply by the derivative of the Tootsie Roll. Okay, the Tootsie Roll center part. Okay? Now, let's get all the dy dx's together and get everything else separate from it. So this will be 6y squared dy dx. Where else do I have a dy dx? I have a dy dx here. I'm going to do some distributive property there too. So I've got a 6x squared dy dx. And I need one more. I've got this one. I've got this one. I need one more. I need a 6 dy dx. Okay? Then I'm going to write everything that doesn't have a dy dx in it. I'll write this as plus 12xy and minus 24x. I think that takes care of all of my terms. Double check my algebra there if you would. Good so far? Do you have your graphing calculators ready? You don't need it in A. You're going to need it in part B. Okay? Just want to make sure you got them ready. Okay, now I'm going to do 2 steps in one. And I think this should be okay in a show that because they're not incredibly difficult steps. I'm going to factor out the dy dx. And I'm going to write this as 6y squared plus 6x squared plus 6. And I'm going to move those 2 terms that don't have dy dx's into them. I'm going to move those onto the other side. And I think this isn't too much of a creative leap, guys. I'll write it as 24x minus 12xy, keeping in mind when I subtract them from the other side, the sign changes. Okay, not too much of a leap there at this point, right? Last step. Divide dy dx is equal to 24x minus 12xy over 6y squared plus 6x squared plus 6. And it matches perfectly the answer they gave us, right? Not quite. What's different? Am I missing? Did I screw something up here? No, I'm good. Okay? There's a 6 taken out of the bottom. So I would write this. I would take a 6 out of the top, and I would take a 6 out of the bottom, and I would manipulate some things to make it look like they want it to look like. So I'm going to say 4x minus 2xy over, I'm going to move the x squared to the front because that's the way they did it. And I will then go ahead and say You don't really want to leave a lot of steps to the reader because the command at the beginning of the problem was show that. I don't know that you need to circle your answer either, but I'm in such a habit of doing it. And those match. Good so far. Okay, so that is a implicit derivative review. Now our goal today is to apply it a little bit. How does implicit derivatives apply to things like tangents and normals and slopes? So we're going to jump to section B. Oh, there's the scoring of it too, by the way. This is scoring shown to us by AP. This part's worth 2 points. 1 point for applying the implicit derivative, and 1 point for verifying it. There's probably some algebraic defense there. So only 2 points for all that stuff. Sorry, it's only worth 2 points. Whole problem's worth 9. Okay? So now, it says write an equation of each horizontal tangent line to the curve. Horizontal tangents. Tell me what you know about horizontal tangents. They're horizontal, their slope is 0. What do I know about slope at this point? Whether or not I did part A, what do I know about slope? Louder. It's what you're going to get from the derivative function. So in this case, horizontal tangent implies that slope equals 0, which implies that dy dx equals 0. This is thinking out loud. May not be worth marks, but I think it's worth writing down. So we have dy dx. What was that dy dx thing again? Make sure I get this right. I don't want to screw this up. All right. 4x minus 2xy divided by x squared plus y squared plus 1 equals 0. So I'm setting dy dx equal to 0. Okay? Quick algebra. You see fractions, part of an equation. Get rid of them. How do you clear fractions? Multiply both sides by the denominator, right? What happens to the left side when I multiply by the denominator? Gone. 4x minus 2xy equals. What happens when I multiply 0 by the denominator? 0. Good understanding to have. And in order for a fraction to be equal to 0, the only chance you got is that the numerator equals 0. There's no way you can manipulate the denominator to make a fraction 0. Won't happen. Okay? Uh-oh. We got x's and y's. We got it set equal to 0. What should we do? Take out something. Mathematically, take out something means, what's the mathematical word for it? Almost rhymes with tractor. Factor. 2x comes out of both of these. There's some solid algebraic manipulation in here, guys. We're not even doing calculus anymore. This is algebra. Setting a derivative equal to 0, factoring and finding the solutions is algebra. So, shall we? What are the x values that makes this expression 0? X equals 0. What's the y value? Y equals 2. So maybe there's horizontal tangents at those points. Now those don't necessarily, it's not necessarily the point 0, 2. Right? It's not necessarily the ordered pair 0, 2, and it's not necessarily even on this function. So if we got a chance to have a horizontal tangent, it could occur at x equals 0, or it could occur at y equals 2. If it did occur at x equals 0, would we know the equation for the horizontal tangent? We would not. We would need the y-coordinate. If there was a horizontal tangent at y equals 2, would we know where it occurred? That's a yes. It would occur at y equals 2. Okay, the only way to be sure is to plug these things back into the original equation. Okay? So, in the original equation, my goodness, what was that? I'm going to go ahead and let x equals 0. If I let x equals, you got your graphing calculators ready? Have I mentioned that yet? Let x equals 0. I think you could probably do this pretty quickly. If I go back to 2y cubed plus 6x squared y minus 12x squared plus 6y equals 1, and I let the x be 0, I end up with 2y cubed plus 6y equals 1. What happened to everything else? It was 0. Okay? Oh, man. Got some algebra again, guys. If I've got a polynomial, what's the easiest way to solve it? Set it equal to 0. Do you guys know how to factor that? Don't feel bad. Do you know how to factor that? Know what you know what you don't know. Do we know how to factor that? Sure don't. Because it's a y cubed and it's weird, right? So, there's 4 things you need to be able to do on your graphing calculator. 1 is find the zeros of the function. 2 is find the numerical derivative. The 3rd and the 4th one I don't remember, but they don't matter right now. I feel like I've said that before. They don't matter right now. We need to find the zeros of a function. I don't know if this is going to show up on the recording or not, but we'll go with it. So go y equals 2x cubed. I realize we're dealing with y's, but play along here. Because the calculator's not going to do a function of y. 6x, oops, I need a plus in there. Plus 6x minus 1. Get a standard window here. And there could be up to 3 zeros of this. But based on what I see in my graphing calculator, probably not going to be 3 zeros. Probably going to be 1. Okay? The question is, where does that 0 occur? Let me make sure I plug that in correctly because I'm second guessing myself for a moment. Okay? All right, let's find the 0. Second, calc, option 2 is 0. Left bound, I've got a negative value, so I'll go ahead and press enter. Arrow a couple right here until I get into the positive world. Press enter again, and the 0 occurs at 0.165. Do we have a horizontal tangent there? Probably. The ordered pair is 0.165. What is the equation for the horizontal tangent? It's a horizontal line. Is it an x equals or a y equals? It's a y equals, and what is the y value there? There's your horizontal tangent right there. Okay? Now, but we're not done. We're not done, guys. We had another candidate for a horizontal tangent. What was it? Y equals 2. So let's go back up here, and let's take that same equation, and let's let y equals 0. Got your graphing calculators ready? So this is going to be 2 times 8, which is 16. Sorry, guys. I was about to do it correctly. I was starting to do it correctly, but I wrote it wrong. Thank you. Y equals 2. That's going to be 16 plus 12x squared minus 12x squared plus 12 equals 1. That's the original equation if y equals 2. Everybody happy? Good? What should we do? Oh, that's weird. What happens? 28 equals 1. It certainly does not. So what do we know? This is what's weird about implicit functions. You may get values for the derivative. When solving with the derivative, you may get values that don't actually work in the original equation. So really, since there is no function, this is kind of like one of those undefined things. If y equals 2, this equation doesn't even exist. So graphically, what does that mean? At y equals 2, there's no function there. So there's either an asymptote there, or you've got some sort of weird relation that's down here and up here. There is no function. There's no equation. I shouldn't say function because it's clearly not a function. It's an implicit equation. There is no curve when y equals 2. So what's our horizontal tangent? Just that one. And there are marks. Here's the mark scheme. There are marks associated with the fact that one of those doesn't give you a tangent line. Okay? One of them doesn't give you a horizontal tangent. Okay? There is no point on the curve with y coordinate 2. All right? Guys, it gets better. It gets better. It can't get worse. All right. Let's go to the last step there. All right. You're gonna have done so many of these by the time that exam comes around in May, you're gonna be like, man, these are the easy ones. Maybe. All right, so just to throw a little curveball at you to demonstrate that you really know what's going on, they give you more. They say the line through the origin with slope equals -1 is tangent to the curve at point P. Find the x and y coordinates of point P. What do we know? We know the slope. The slope is -1. So we know, and what's the y-intercept? If it goes through the origin, the y-intercept is 0. So y equals -1x is tangent to the curve. And we know the slope. There's two ways to approach this. You want the easy way or the hard way? You want the hard way? There's a way that requires a calculator and a way that doesn't. I'm going to show you the way they suggest. They will accept either one, and I'll show you the mark scheme with the other one. The most efficient way to do this is to set slope equal to -1. And we have slope. What's slope? That's dy dx. Okay, this is the smoothest way to do this problem. You can do it another way. There's our slope equals -1. Okay? Now, it's important to note at this point that this equation also represents a point on this curve. A point on the slope shares this. That's going to be important in just a moment. So I'm going to go ahead and write this out. 4x minus 2xy is equal to -x squared minus y squared minus 1. What did I do? Multiplied by the denominator. I like polynomials. I don't like fractions. Okay? At this point, then, I'll move everything back over by adding it to this side. I'll have x squared plus 4x plus y squared minus 2xy plus 1 equals 0. Now, I hope if you were to revisit your higher algebra days or your pre-calc days, you might come to a conclusion here. I've got one equation and I've got two variables. I have a problem. What do I need? If I have one equation, two variables, I don't have enough of something. I need one more of something. What do I need? Another equation. Do we have another equation? Let's go slide back up here so I can find it for you. Do we have another equation? We sure do. Y is equal to -1 times x. So what should we do? Substitute -1x for all the y's. So this is x squared plus 4x plus -x squared minus 2x -x plus 1 equals 0. We now have used a process called substitution, and we have an equation with all x's in it. You can kind of work along the way as I go here. Try to finish this up somewhat quickly. Okay? So now, I'll do some distributing. I've got x squared plus 4x plus x squared. Negative and negative, that's plus 2x squared plus 1 equals 0. Now I need to combine some like terms. X squared, 2x squared, that's 4x squared plus 4x plus 1 equals 0. We are now back in the world of nice factorable quadratics. Can we? Quadratic equals 0, you want to consider this. There's factors that'll work. What? Does this work? Whoops. Does that work? If I FOIL, I get 4x squared, 4x, 1x. That's not going to give me what I want. 2x on both of them. Both work. So what's that give us? A double solution. X equals what? Negative 1/2. Question. Yes, you can. Yep. Can you use, the question is, can you use your calculator? Not on the whole exam, but on the calculator allowed parts you can. Now, we already agreed at the beginning of the hour that this was a calculator allowed problem. Okay? So, wait a minute. We did something, but let's go back to the top, guys. It says, find the x and y coordinates of P. What did we find? We found the x coordinate. This is an x coordinate. We're halfway there. How do we find the y coordinate? You plug it in to what? The easier one or the hard one? Let's do this one. Isn't y equal to negative 1x? So y is equal to negative 1 times negative 1/2, so y is positive 1/2. So the ordered pair, negative 1/2, comma 1/2, is the coordinates of that point. Question. Right here, this one? The one below that, this one. Good question. This becomes positive because it's negative x times negative x. Okay? Your job for the evening, we have a partner quiz tomorrow. I want you to look at the other worksheet I gave you, and I want you to try 3.8 day 2.